Hi everyone! So we are going to be talking about transformations of quadratic functions today. Some of the terminology will sound familiar because we have gone over transformations of linear functions a lot, and so that will kind of help you remember some of those things because some transformations are similar. First, we're going to start out by writing down this transformation form that's at the top that I wrote in at the top here. And it's y equals a times x minus c squared plus d. So we'll see that a few times throughout the notes today. It's just kind of a good thing to keep at the top so you remember all the different transformations that we talk about today. So first, we're going to start with the parent function. The parent function of quadratics is y equals x squared. And we are going to fill in the table of the parent function and then graph it real quick. We did this with our intro to quadratics unit. And so it should seem familiar. To do that, I'm going to type it into y equals on my calculator. So if you want to pull your calculator up, I'm going old school today and actually using the real calculator. I know it's been a while since we've seen one of these. So I'm going to go to y equals, type in x squared, and graph it. We all know the parent function looks like it starts at the origin. It's just an upwards facing u. I'm actually going to go straight to the table though, so that we can fill in those values that are on our notes sheet. So we're starting with -2. The y value is 4, 1, 0, 1, 4. So I'm going to switch back over and fill those in. 4, 1, 0, 1, 4. We could also get those values algebraically. Remember, we would just plug in these different x values into the parent function. So an example of that would be me replacing the x value with -2. -2 squared is 4. That's like -2 times -2. So I'm going to plot those points on this graph over here to the right. -2, 4 is there. -1, 1, 0, 0. And then it goes back up on the other side. 1, 1, 2, 4. So that parent function, that's where all of our other functions will be based off of. So the transformations we learned today will be changing that function in some way. Just another reminder here, the domain of f of x, or that function we just graphed right there, would be all real numbers. It continues left and right forever and ever. The range of our parent function, the lowest y value is here at 0, and the rest of them go up from there forever. So our range would be y is greater than or equal to 0. This 0 should also match the y value of our vertex at 0, 0. So in this first activity, activity 1, labeled here, we are going to be talking about the transformation that happens in position A of our transformation form. So we are talking about this A right here in the front. Before we graph these new equations, I want us to start by graphing the parent function again. So I'm going to do that here first, just to kind of sketch it out really quick so that we know we can actually like visually see what these transformations do. So that's our parent function. Now we're going to start with graphing 5x squared. So I'm going to do that one in blue. And I'll type that into my calculator next, 5x squared. And I see a U shape that looks pretty similar to the parent function. So something that might be helpful is if I also graph, like in y2, the parent function, so I can see the difference. So the parent function will be the second one that gets graphed. There we go. So the parent function is this one right here, and 5x squared is this one that's in the middle of it. So I would say that it looks like putting a 5 in front of the x squared made our parabola get skinnier or narrower. So that is what we are going to look at here. So I'm just going to sketch that blue function in the middle of the parent function over here on the graph. So it's narrower than the parent function. The domain is still all real numbers. And if I think about the range, it didn't move. It just got skinnier. So the range is still going to be the same as the parent function. It'll still be y is greater than or equal to 0. Okay, so that's what it looks like when we've changed this number in front of the x squared to a 5. Now let's see what happens when we have a 1/4 in front of our parent function. So on my calculator, I'm going to change this function. Remember, alpha y equals, enter will give you that fraction. Alpha y equals, enter. So 1/4 x squared, and then we'll graph it. So the first one we see will be 1/4 x squared. Whoa, that one looks way different. And then the parent function's back in the middle. So think about how would you describe the difference between 1/4 x squared and the parent function? I would say that it got wider. So I'm going to use pink for this one. I'm just going to sketch that in here, showing that this one got wider. And it would still have a domain of all real numbers. It still has a vertex at the origin. So our range is still y is greater than or equal to 0. And that means that if we have a fraction in the front, it's going to make our function get wider. The last one here is what is going to happen if there's a negative sign in front of x squared. And we may have mentioned this in class before, but we're just going to graph it really quick in case you don't know. But a negative x squared function, so changing my y1 to negative x squared, make sure you use this negative symbol down here. It flips it over, or it reflects the parent function. That's what changes our parabola from having a minimum to having a maximum. So lots of things to add here. So this green one that I draw on is going to be the same width as the parent function, but it's just going to be reflected over the x-axis. So it's flipped or reflected over the x-axis. So anytime there's a negative sign in the front, so we could have a negative sign and a number, and it would do both things. But it's still going to have a domain of all real numbers. However, the range has changed now because we're still at the origin for the vertex, but now that my function flipped over, the y values are all going to be less than or equal to 0, because 0 is the highest y value now, and the rest down this whole entire function are less than 0. So less than or equal to 0 for the range. So to summarize this, down below, if A is, or if the absolute value of A is greater than 1, so that means the positive amount of A, if it's a whole number bigger than 1, the graph gets narrower. It gets skinnier. If A is a fraction, or if it's in between 0 and 1, the graph gets wider. So this one on the top was if A was a whole number. This one is if A is a fraction. And then the last thing is if A is less than 0, the graph flips. So that happens when A is negative. So these are all of the A transformations. Our graph is either going to get narrower if A is greater than 1. It's going to get wider if A is a fraction, and it's going to flip over if A is a negative number. So if you need to pause here to catch up on that last section, go for it. But we're going to move right along to activity 2. In activity 2, we're going to talk about the D transformation. So y equals ax minus c squared plus d. So we're talking about D in this section. And this will probably seem very similar to what we talked about with linear functions, because D at the end does what it looks like it's going to do, as in if it's positive, it's going to move up, and if it's negative, it's going to move down. Little spoiler for you, but we're still going to go through and discover those things as well. So I'm going to sketch the parent function again, just so we have something to base all of this off of. So that parent function is what I'm putting on there first. And we're going to start by looking at the graph of y equals x squared plus 5. So since we're super duper smart, and you just listened to me talk about what D is going to do, you might be thinking to yourself, this might move the function up 5. So let's see if that's right. So I'm going to switch over to the calculator. Let's graph it after this announcement. So in y1, I'm going to graph x squared plus 5. And then I still have the parent function in y2. Graph. First function, boom, moves up 5. Parent function obviously stayed where it was. So when we see a positive D value at the end of our function, that is going to move the graph up 5. That's called a shift up 5. So it vertically shifted 1, 2, 3, 4, 5 units up. It's still the same width as the parent function because there's no number here in front of the x squared. Just moved it straight up. So the domain, all real numbers. The range, now think about your y values. The range is now the lowest value at 5, and all of the y values go up from there. So that would be a range of y is greater than or equal to 5. Wonderful. Now let's see what happens when we graph x squared minus 3. Bet you can't guess what happens. Let's look. So we've got y1, changing it to x squared minus 3. Graph it. And look at that. It moved down 3 units. Just like we thought it might. So this would be a shift down 3. 1, 2, 3. Sketch it out. Oh, beautiful. Oh, that looks so bad. Okay, the domain, all real numbers. Spoiler alert. Could probably fill that in for the rest of the notes sheet. The range, it's still an upwards facing U, so our symbol should still be greater than or equal to, but now our vertex moved down to 0, -3. So that means y is greater than or equal to -3 will be our range. Now this last example does all the things. It's got a negative sign in the front of x squared. It's also got a 3 in front of x squared.
Release group B.
And it's got a +1 at the end. So there are 3 transformations happening to this one function right now. A negative sign, a 3, and a 1 at the end. All right, so this one we're going to use pink for. Let's go one by one. Before even looking at the graph, let's see if we can figure this out. And by we, I mean me, because it's just me doing this video right now. But anyway, the negative sign. Think back to the A transformation. A negative sign in front of the x squared is going to flip or reflect over the x-axis. Okay, so that's the negative sign. Now moving from left to right. Next we see a 3. Well, going back to the A's, I think a 3 will be similar to this 5 right here, and it's going to make the function narrower. And then the last thing is there's a +1 at the very end. Well, a +1 will be like this +5. It should move up 1. Just to verify and to make sure our sketch looks great, let's put that in the calculator real quick. So we've got, -3x squared plus 1. So we should see all 3 of those things happen when I hit graph. It's flipped, it's narrower, and it moved up 1. Okay, so note where the vertex is right here. Maybe if I couldn't see it, I might look at the the table, and get some points from the table. But my y-intercept moves up to 0, 1. So let's put that on our graph now. A vertex of 0, 1, it's narrower, and it's reflected or flipped over. So that would be what this quadratic would look like. Domain, all real numbers. Range has changed now because it's flipped over. So I think about what's the highest y value of my function? Well, that's a +1. And then it's going to be less than or equal to 1 because it's flipped over.
C. Release group C.
So flipping it over made us have a maximum. So that will be y is less than or equal to 1 for the range. Summary time. If we see plus d, plus a number at the end of the function, that's a shift up. And if we see minus d at the end of the function, that's a shift down. Pretty easy summary. D is a little bit easier than C. That's why we did this one first. Saved the trickiest one for last. Okay, so our last activity here, y equals a times x minus c squared plus d. We're now going to talk about c. Before I do these examples, I want you to think about the forms of quadratic functions that we've learned so far. So standard, vertex, and intercept form. This looks extremely similar to one of those forms we've talked about. Think about that for a second. Which form does this look like? I'm sure you're all shouting vertex form right now. I can hear you through the video. So this is really going to do the same thing that vertex form does. Think about in vertex form, we talked about what we have to do to this number when we take it out of parentheses for the vertex. Do you remember? We have to change the sign. Okay, so we've got to be thinking of that opposite business because it's the one in parentheses. So when we take it out, be thinking opposite, okay? So let's get going on these here. Of course, sketching the parent function. Then we're going to start by graphing this on the calculator. All right, so let's go over there. Go to y1 and type in using parentheses, just like you see it, x plus 5 squared. Okay, so x plus 5 in parentheses squared. Whoa, craziness. So it looks like the same width, but we went from parent function here to moving over to the left, and it moved over 5 units to the left, okay? So remember, that's what it looked like, 5 units to the left. Our vertex is at 0, -5. So looking at this equation right here, if you think about it, we have to think opposite. So this inside the parentheses is going to take us either to the left or the right. And since I see a plus 5 in parentheses, that means the vertex moved to the left 5 units. 1, 2, 3, 4, 5. Okay, so this is the think opposite transformation. This was a shift to the left 5. So if I see a plus 5 in parentheses, that really means I moved to the left 5. Since we're already experts on vertex form before we finish this one out, let's think about where the vertex of this one would be based on the equation. Okay, so we know for vertex form, this is the x value of our vertex, but we have to change the sign. So that means it would be at -5. And then the y value of our vertex comes from this back part of the equation back here. But guess what? There's nothing there. So that means it's a 0. So using vertex form, we could also complete this transformation because it did exactly what we thought it would, move to the left 5. Or it moved our vertex to -5, 0. So amazing. I know, you're overwhelmed. Okay, so the domain of this one, all real numbers. Big surprise. The range, thinking about our y value still stayed at 0, and it's facing up, so that would be greater than or equal to 0. Okay, then we've got the next one changes to a minus in the parentheses. but there's a 2 out in front, so it's going to do 2 things, okay? So A, this one has an A value of 2. It's got a 2 in the front. Do you want me to say 2 again? 2, okay. So if we think back to A, an A value of 2 would be like this one. It's going to make our function narrower. And if we're thinking opposite like we should be, this one is probably going to move to the right too, because we see a -2 in the parentheses, so that would make it go to the right too. Let's graph it really, really fast. You can just watch me do it this time. Okay, so 2x minus 2 squared. Graph. There it is. It moved to the right 2 units, and it does look a little narrower. So that's what we're going to sketch. Moved it to the right 2, so 2 units this way for the vertex, and make it look narrower than the parent function. So this vertex moved to +2, 0. Domain, all real numbers. Range, didn't change either. Its y is greater than or equal to 0. Okay, and then the last one is going to do like all the things. So we have a 4 in the front. A 4 in the front means, again, our function will get narrower. So that's the 4. Then a +3 in parentheses is going to be a move to the left 3, because we have to think opposite because it's the one in parentheses. And then -2 at the end. Think about where -2 would make it move outside of parentheses. That's down 2. Let's use our amazing vertex form real quick. We have a +3 in parentheses and -2 outside. So our vertex, thinking opposite for the x value of the vertex, is going to be -3. The y value is this number out here, -2. So we already know where the vertex should move. Let's put that on our graph. It's at -3, -2. And for the sake of time, we're just going to draw it as a narrower function that opens up at -3, -2. You can graph it on your calculator if you don't believe me. So we've got all real numbers for the domain. The range has changed a little bit because our vertex is down here now. The lowest y value is going to be -2, and it's still going to be greater than or equal to because this one opens up. For our summary, we're going to remember that if we see in parentheses x minus c squared, that's going to be a shift to the right. And then if we see x plus c squared in the parentheses, that's going to be a shift to the left. So we've got this one tricky one where we have to think opposite, which is still similar to what we did with linear functions. So you might not be as tripped up by that as I would think. And then we've got the plus d at the end, or minus d, that goes up and down wherever you think it would go. So +5 moves up 5, -3 moves down 3. And then a will change the width of the function. So whether it gets narrower if there's a whole number out there, or wider if there's a fraction.